Question 6 says PQR is an isosceles triangle with PR equals to QR. QR is an isosceles triangle with PR equals to QR. P is the 0.15 and Q is the 0.51. So let's start with plotting the points first. P is 1,5, so that's going to be P, and Q is 5,1. Okay. They said PR equals to QR, so this will be R then, because that shows equal distance. But angle PRQ is not a right triangle. So that means this cannot be R, because if we draw R over here and connect the points, that's going to be right angle triangle. So that can't be R. Find the coordinates for one possible position of R. You may use the grid to help you. So we have to make sure that PR is equal to QR. So let's say if you put R over here, so this is 6 and 6. So if you find the distance of a P from 6, 6 and Q from 6, 6, so I'm going to call P to 6 is D1. So that's going to be 6 minus 5 whole square plus 6 minus 1 whole square. So that's going to be 1 square plus 5 square, which is 1 plus 25, and that's root 26. If I find D2, which is Q from this point, that's going to be 6 minus 5, 6 minus 1 whole square, plus 6 minus 5 whole square, which is also the same thing, root 26. So we can assume that R is 6, 6, because if we join this over here, that is not a right angle triangle. So 6, 6. Part B says here are the equations of the 5 curves. Y equals to 2 minus x square, y equals to x cube minus 2, y equals to x square plus 2x minus 8, y equals to x cube minus 3x, and y equals to x square minus 3x. Sketches of 3 of these curves are drawn below. Write the correct equation underneath each sketch. So if you look at the first one, that's a quadratic equation. Like it's a quadratic curve, but it's a minimum quadratic curve. Now, what is a minimum quadratic curve? A minimum quadratic curve would have the x square value as a positive value. Basically, your a value would be greater than 0. For a maximum curve, which is this one, your a value would be less than 0. So when I talk about the a value, that's basically your ax square plus bx plus c, which is the coefficient of x square. So if the coefficient of x square is greater than 0, it's a minimum curve. If the coefficient of x square is less than 0, it's a maximum curve. Whereas the third one is a cubic curve because it has 2 turning points. So going back to the equations, now if we look at our given equations, a value is greater than 0 in this one and this one. Now we look at the x-intercepts. So for the x-intercepts, we know this is 0 over here, and this is some positive x value. So for positive x value and 0, we know that if we factorize x squared minus 3x, x squared minus 3x would be x times x minus 3, which means one value of x would be 0 and the other would be positive 3. Hence, first is y equals to x squared minus 3x. Yes, we do have another quadratic equation, which is y equals to x squared plus 2x minus 8, which is for a minimum curve. But if we had factorized it, we wouldn't have gotten x equals to 0 as one of the factors. It would have been 4 and 2. So that's out of our options. Then for the maximum curve, there's only one maximum curve, which is this one. Y equals to 2 minus x squared. As you can see, x squared is negative. That means this is our equation for this curve. And lastly, for the cubic curve, we have two cubic curve equations. Y equals to x cubed minus 2 and y equals to x cubed minus 3x. Now, in this case, our equation will be y equals to x cubed minus 2. Why? Because as you can see, the graph has been shifted downwards. So since there's a downward translation, that means your y-intercept is a negative number. And over here, if we put the equation equal to 0, if we put x equals to 0 in this cubic curve, we see that y is negative 2 when x is 0. So that is this point. Hence, y is x cubed minus 2. Part C says A is the point -1, -5, B is the point 3, 3. Find the equation of the line perpendicular to AB, which passes through the midpoint of AB. So let's start with finding the midpoint of AB, which is going to be x1 plus x2 over 2, y1 plus y2 over 2. So that's -1 plus 3 over 2, -5 plus 3 over 2. -1 plus 3 is 2, and 2 divided by 2 is 1. -5 plus 3 is -2, and -2 divided by 2 is -1. So that's our midpoint of AB. Then it says find the equation of the line perpendicular to AB. So next what we do is we find the gradient of AB, which is y2 minus y1 over x2 minus x1, 3 minus -5 over 3 minus -1. 3 plus 5 over 3 plus 1, 8 over 4, and that is 2. So this and this. For the y2 and y1 and x2 and x1, I chose B as y2, x2. This is y1 and this is x1. You could have swapped it as well. A could have been x2 and y2, and B could have been x1 and y1. So there's no restriction on that. So now that we have M of AB, since this line is perpendicular to AB, which means gradient of the line would be -1 over 2. Why? Because if you remember the condition M1 times M2 equals to -1, 2 times M2 is -1, which means M2 would be -1 over 2. So now that we have the gradient, we have our point. We can just find the line of equation by doing y minus y1 equals to m times x minus x1, y minus -1 equals to -1 over 2 times x minus 1, 2 times y plus 1 equals to -x plus 1. I'm just going to erase this part over here. 2y plus 2 equals to minus x plus 1. 2y equals to minus x plus 1 minus 2, which is 2y equals to -x minus 1, and y is -x over 2 minus 1 over 2. That is your line of equation for the line that is perpendicular to AB and passes through the midpoint of AB. Question 7 says a rectangular field measures 30 meters by 45 meters. Calculate the perimeter. So for the perimeter, we'll do 2 times the sum of 30 and 45. which is 2 times 75. And that is 150 meters. Calculate the length of the diagonal. So if we draw the rectangle, this is our 30, this is our 45. So this is the diagonal that we have to find. We use Pythagoras. X square equals to 30 square plus 45 square. X equals to square root of 30 square plus 45 square. So if we solve that, it is 54.08 meters. Part B says the diagram shows a sketch of triangle PQR. All lengths are given in centimeters. Calculate the length of A. So as you can see, we have like some expressions or something for all the three lengths, and we have one angle given. So that means we can easily apply the cosine rule. Your cosine rule is A square equals to B square plus C square minus 2BC cos of A. Like that's like one version of it. Like there are three different forms depending on which length you're trying to find. In this case, since angle R is given, so we'll make PQ the subject of the equation. So PQ square equals to PR square plus RQ square minus 2 times PR times RQ cos of R. So basically in this, what happens is that you use that length as the subject whose opposite angle is given. So the opposite angle for PQ is angle R. For PR, it would be angle Q, and for RQ, it would be angle P. So now we substitute the values. A plus 4 whole square equals to A square plus 11 square minus 2 times A times 11 times cos of 60. A plus 4 whole square is A plus 4 whole square is A square plus 8A plus 16 and A square plus 121 minus 22A, and cos of 60 has the value of 0.5. So A square plus 8A plus 16 equals to A square plus 121 minus 11A. A squares get cancelled out because when we take A square to the other side, it would be A square minus A square. 8A plus 11A, I moved 11A to the other side, and I brought 16 to the right-hand side. So now we have 8A plus 11A, which is 19A, and 121 minus 16, which is 105. So A would be 5 divided by 19, which equals 5.53 centimeters. Part C says the diagram shows a sketch of a quadrilateral ABCD. All lengths are given in centimeters. The area of the quadrilateral is 70 centimeters square. Calculate DAB. So what we can do is we can start with finding the area of the triangle ACD, which is 1/2 times base times height. Base is 10 and height is 8. So that's going to be 40 centimeters square. That means area of triangle ABC, area of triangle ABC would be 70 minus 40, which is 30 centimeters square. So we can find, since this is the angle that we're trying to find, so we can find this angle by using the formula of area of triangles, which is area of non-right angle triangles, which is 1/2 times. We can find the angle CAB by using the formula of the area of non-right angle triangles. Non-right angle triangles, which is 1/2 AB sine of angle C. So this formula is applicable when you have two lengths and the angle between them. So in our case, since we have two lengths, AC and AB, and we're trying to find the angle between them, which is going to give us the DAB complete angle. So we're going to do 30, which is the area of this triangle, equal to 1/2 times 8 times 9 times sine of A over here. So I'm going to move the calculation over here. 30 equals to 4 times 9 times sine of angle A, and 30 divided by 36. And then we take the sine inverse of that. So sine inverse of 30 divided by 36 is 56.44. Now that we have this angle, 56.44, we're going to find the remaining angle. So we're going to remove all of this. For the remaining angle, what we can do is, since this is a right angle triangle, we have the opposite and the adjacent, so we can use tangent. So tangent is opposite over adjacent. So it's going to be, opposite is going to be 10, and 8 is going to be our adjacent. So 10 over 8, and A is going to be tan inverse of 10 over 8, which is going to equal to 51.34. So that means total angle DAB, which is going to be the sum of both these angles, is going to be 56.44 plus 51.34, 107.78 degrees. Question 8 says we have two functions and they want us to find f of -2 first. So f of -2 is 3 times -2 minus 5, which is -6 minus 5. That gives us -11. Then it says, find the largest integer satisfying f of x greater than 3gx. So 3x minus 5 greater than 3 times 4x plus 4 over 3. 3x minus 5 is greater than 4x plus 4. I'm going to take 4x to the left-hand side, and I'm going to take 4x to the left-hand side and 5 to the right-hand side. So we have 3x minus 4x greater than 4 plus 5, negative x greater than 9. So since there's a negative sign with x, we're going to divide both sides by -1. And when we do that, we flip the inequality as well. So that's going to be x less than -9. So since it's less than 9, so it's going to be -10. That is your largest integer value. Solve f of x equals to g of 3x minus 5. So f of x is 3x minus 5. And g of x was 4x, 4x plus 4 over 3. So if g of x is 4x plus 4 over 3, then g of 3x minus 5 will be 4 times 3x minus 5 plus 4 over 3. Basically, we're changing the domain from x to 3x minus 5. So that's 12x minus 5. That's 12x minus 20 plus 4 over 3, which is 12x minus 16 over 3. So now we put that over here. 12x minus 16 over 3, which is going to be 3x minus 5 times 3 equals to 12x minus 16. 9x minus 15 equals to 12x minus 16. 9x minus 12x equals to negative 16 plus 15. Negative 3x equals to negative 1, and x is 1 over 3. Solve g inverse of x equals to 5. So g of x is 4x plus 4 over 3. So first we find the inverse. We put g of x equals to y. So y equals to 4x plus 4 over 3. Cross multiply, 3y equals to 4x plus 4. Move 4 to the other side. 3y minus 4 equals to 4x. And then finally divide it by 4. So that means your g inverse x is 3x minus 4 over 4. Now we put this equal to 5. So it's going to be 20 equals to 3x minus 4. 20 plus 4 equals to 3x, which is 24. So x is 24 over 3, which is 8. Question 9 gives us a cone, and they have given the formula for the volume of the cone and the curved surface area of a cone. A cone has radius of 6 centimeters and a slant height of L centimeters. The total surface area of the cone is 84 pi centimeter square. Show that L equals to 8. So I'm just going to draw this line over here. So they have told us that the total surface area is 84 pi. 84 pi. So total surface area is going to equal to pi r square plus pi r L. 84 pi is equal to pi times 6 square plus pi times 6 times L. So 84 pi is equal to 36 pi plus 6 pi L. We do 84 pi minus 36 pi, which is going to be 48 pi. And then we divide 48 pi by 6 pi, and that is equal to 8 centimeters for L. Then it says calculate the volume of the cone. So volume of the cone, for that, just going to go back to drawing that line again, which is basically for our height. So first we need to find the value of the height using Pythagoras, because this is a right angle triangle. So L square equals to H square equals to R. L square equals to H square plus R square. L is 8 square. 8 square plus 6 square. So that's 64 equals to 8 square plus 36. 64 minus 36. which is going to give us 28, and then we take the square root of 28, which is 5.29. So now we will use this value to find the volume. So volume will be 1/3 pi times 6 square times 5.29 5 times 5.29 divided by 3. That's 199.43 centimeter cube. Part C says a similar cone has a total surface area of 47.25 pi centimeter square. Find the radius of this cone. We just know that the surface area of our cone is, total surface area of our cone is 84 pi. So we'll do surface area 1 divided by surface area 2 equals to R1 over R2 square. So surface area 1 is 84 pi. So 84 pi divided by surface area 2, which is 47.25 pi, equals to R1, which is 6, and R2 is an unknown, which we have to find. So this is the rule for similar shapes. Like whenever like you have two similar shapes and they've given us the area or like one of the like the lens, and they want us to find like one of the unknown values, like either the area of the other shape or the length of the other shape, what we can do is we can create fractions for the surface area or just the area and put that equal to the square of the corresponding ratio of their lengths. And if like we have given, like they're talking about volume, so then what you do is instead of squaring the ratio of lengths, you cube the ratio of lengths. So basically area 1 over area 2 would be L1 over L2 whole square. And for volume, so volume 1 over volume 2 equal to L1 over L2 cube. This is a condition for similar shapes. So going back to our question, we do 84 pi divided by 47.25 pi. We divide 84 by 47.25 because the pi's get cancelled out. So 84 divided by 47.25 is 1.7 recurring. And then I'm going to square root this and write 6 over R2 over here. So now if I square root 1.777, so that's 1.333 equals to 6 over R2. R2 is going to be 6 divided by this, and that is going to equal to 4.5 centimeters.